Okay, so let's start with day 4, guys. Now, so if you see, first we will see the security zones. What is the concept of zone? Then we will see different types of interfaces. What is tap mode, decryption mirror, virtual wire, layer 2, layer 3, HA, aggregate interfaces. We will see what is virtual router, how we can configure the IP address on the Palo Alto firewall. What is the concept of DHCP client, server, and relay on Palo Alto? What is the concept of, okay, virtual router is, I have repeated 2 times. Okay, don't worry. After we will see dual ISP scenario as well. What is the path monitoring? What is the policy based forwarding? And what is the equal cost multipathing? I have also put these 2 links, guys, for your reference if you want to learn more about this PVF and ECMP, guys. Okay. I will use this particular topology. On this topology, what? I am having my Palo Alto firewall, which is this one. This Palo Alto, I have one interface which have a connectivity with the ISP01. Let's suppose this is a Tata ISP, and I'm using 151.7.0/24 subnet here. I'm having another interface Ethernet 1/2 which connects with the ISP2, which is a Airtel. So this is my primary link. This is my secondary link. Okay, and I am using here 161.7.0/24. After that, these ISP have a further connectivity with this one of the router here as well. Okay, so these 2 interfaces I will put into a zone which is outside zone. This is my management interface. This is my inside interface that's have a connectivity with this particular switch. And behind this switch, I'm having 10.1.2.0 subnet, 10.1.5.0 subnet. I'll having this behind this router, and this interface having subnet which is 10.1.3.0, and this here I'm having 10.1.4.0/24. I'll configure this switch as well with the SVI with the VLANs. Okay, I'm also having DMZ router where I'm having 10.2.2.0/24 subnet, right? I'll use here 100, and what I will do, I will also create a 2 loopback interface, loopback 1 or maybe loopback 10 and loopback 20, where I will use 10.2.10.0/24 subnet, and in 20 I will use 10.2.20.0/24 subnet. This kind of subnet I will use behind this one, and after we will see how we can add different routes and all these kind of things. Basically, we will discuss, guys. Okay. So what I can do, let me start with the theory first. What is the concept of security zones? Okay. So basically, Palo Alto firewall is a zone-based firewall, guys. Zone-based firewall means whatever interfaces you are having, you have to put these interfaces in a zone, guys. You have to configure a zone with an interface. Okay. So let's suppose this is my firewall. If I have a connectivity with the internet, that time I will put this particular interface in a zone which is maybe outside zone or maybe untrust zone. Okay. If I'm having, let's say I'm having this particular behind this center, I'm having these data centers, so I can maybe give the name to this interface like as a DC interface, DC zone. Here I am having users, so maybe I can give a like users zone. Here I am having guests, so I can create a guest zone, and I will put all my interfaces where my guests are coming. If I'm having DMZ servers, so I will put the interface who connects with DMZ servers into the DMZ zone, right? So, and also you have to remember one more thing, guys. Palo Alto firewall is a zone-based firewall. Why we will create these zones? Because when we write the security rules, net rules, we have to write on the basis of zone, guys. Okay. So that's why it's a zone-based firewall. So this is the concept of security zones. Then we are having interface types. Okay, so before going into these interface types, what I can do, let me just go into this topology. Let me just open my firewall. This firewall got the IP address from DHC, which is 192.160.137.128. What I'll just try to access this particular firewall on that IP address, which is 192.168.137.128. Enter. Enter. Login. Username is admin, password is admin. I'll just log in into my firewall here. So it's loading. So we will wait here for some time. Now I'll go into my network tab. In network tab, if I'll go into the interfaces, this is the place, guys, from where we will create a zones. Okay, zones we will create from here. Now I have a interfaces. Now if I'll go inside this interfaces, if you see interface type, so in Palo Alto Firewall, I'm having different types of interfaces like tap interfaces there, HA type is there, virtual wire type is there, layer 2 type is there, layer 3 type is there. These are the different types which I am having in my Palo Alto Firewall. Okay, so let me just explain each and every types, guys. Okay, so if I'll go into the interface types, this particular diagram. So guys, if you see here, I'll always use this particular tap mode when I want to put a firewall in a side. So let's suppose you are having existing network, right? Your network is running, you are having your legacy firewall, which is here, and you are having existing network. Right? Now you have a one requirement in your organization. What? You want only monitoring actually. You don't want to block the traffic. You just want to monitor the traffic. Means you have to monitor. In that case, what you can do, whatever interface you are having in your Palo Alto firewall, just configure this interface in a tap mode, guys. So what it will do, and configure the span on your this particular switch, because it's a core switch. All the traffic will go through this particular switch only, right? So the thing is, whatever traffic is basically received by this switch, he will send the exact copy to your firewall. Now on your firewall, you can able to generate the alerts actually with regards to if there is any threats, if what kind of traffic is going on. You can get all these things, guys. Means when you configure your firewall in a tap mode, this is also known as like tap mode deployment or a promiscuous mode deployment. Here you will not able to block the traffic, you only able to see the alert actually. Okay, so means you will get the visibility of your network if you will put your firewall into the tap mode deployment. So if you want to configure your firewall in this deployment, you have to basically select the interface type as a tap. We have a we are having a like dedicated lecture for the actual configuration of these modes, guys. Here I am just covering the theory part. Okay, now there is a one more type of interface, is a virtual wire interface. So the thing is, if you see the limitation in tap mode is we cannot able to block the traffic, right? Because it will only give you the visibility. So the thing is, upgrade of tap mode is your virtual wire mode. In virtual wire mode, what you can do, you can port the firewalls inline to your network, and all the traffic will go through your firewall. Now you can write the security policy. Here you can also alert the traffic, and also you can block the traffic. It means you can deny the traffic, because right now your firewall is in inline. This virtual wire deployment is also known as a like bump in the wire deployment or a transparent deployment, because if you want to deploy your firewall into virtual wire mode, what you have to do, you don't need to modify anything. Whatever routing protocol you are running between this segment and this segment, you don't need to modify it. Whatever IP schemes you are running here, you don't need to modify. What? Just cut this cable into two pieces and connect one part here and one part here. So the thing in that case, basically this deployment is known as a virtual wire deployment. And also, guys, whatever devices you are having, like this device and this device, they are not aware about that there is a firewall in middle, because it's just transparent to the network. Okay, and if you configure your firewall into the virtual wire deployment, you can able to configure the rule on the basis of app ID, content ID, user ID. You can also allow to configure SSL decryption. You can also allow to configure the net if you want, guys, on your firewall. And after that, we are having layer 3 deployment. In layer 3 deployment, so guys, generally 99% deployment of Palo Alto will be in layer 3 deployment, where you have to configure the IP address into both the interfaces. And we will also do almost all the labs into your layer 3 deployment. Okay, where we are having different segment here, different network segment here, configure the IP address, configure the routing, configure the VPNs. So in layer 3, almost you can able to basically achieve all the features. If you want to configure the routing protocol, you can able to do that, right, on this firewall. You can able to, you are allowed to configure the VPNs. All these kind of features are there into your layer 3 deployment, guys. Now I'll go here. Let me just open. There is a one more image I'm having. This is another diagram which I have taken, guys. So if you see here, this is a perfect example of tap mode deployment, guys, where this is your actual network, but you have configured your firewall in a side. You have configured this interface in a tap mode, and you have configured the span on this switch. So switch will forward all the traffic to your firewall, and your firewall generate the alert. Okay. This is your virtual wire deployment, guys, where you are having your existing setup. This is your legacy firewall, and here you have put the firewall. So by using this legacy firewall, you can able to configure the rule on the L3 and L4 information, and you can configure the layer 7 features here actually. Okay, so these kind of features you can configure here. Now you will also have a one more deployment mode, which is layer 2 deployment, guys. So generally you are having LAN segment, you are having servers zone, right? Let's suppose if you are having switch here, right, and this is also part of VLAN 10, this is also part of VLAN 10, right? They can communicate with these servers directly, right? But if you want to protect your server from these access of these LAN users, means only specific user can able to access, what you can configure your firewall here, put this particular interface in a VLAN, this interface also in a VLAN, and just configure your security policy. So let me also give you one more example for layer 2 deployment, which is the most preferred one actually, guys, in industry. So let me open my notepad. So generally, if you aware about the 3-tier architecture of an application, generally every application, guys, let's say we are having one e-commerce application. So when we deploy these applications, they are having 3 tiers actually. So what, let's say I'm having here my switch. Let's say this is my switch. This switch have a connectivity with one of the firewall. That firewall have a further connectivity with the internet. Okay. Now this switch also having these interfaces. F0/1, this interface is F0/0, then we are having F0/2, and we are having F0/3. Behind this interface, let's say we are having web servers. These are my web servers, guys. Server 1, server 2, and server 3. Behind this F2 interface, I am having my application servers. App servers. Server 1, server 2, and server 3. Okay, now we have one more interface, which is F0/. Behind this interface, what I am having my database servers. Server 1, server 2, and server 3. Okay, so generally, guys, if people who is coming from outside, right? If there is a person who is coming from outside, okay, so that to outside people, what we always give the access of our web tier only. We always give the direct access of web servers. We don't allow the access of our application servers or our database servers. Okay, so let's suppose we are hosting one e-commerce website. Okay, so let's suppose we where there is a one tech one basically, let's suppose there is a one watch. Okay, that watch this particular user wants to purchase. So what he will do, he will access this watch via in the servers. He will access one of the servers. From there, what he will just try to fetch some more information regarding this watch. So what they will do, these server will contact with the application servers, right? And they will get the information from app. After that, they will reply with that information to this particular user who is in outside, right? When this particular user, he see the information of this watch, and now he just do the transaction, right? So that transaction information is what, for doing the transaction, this web server, they will contact to database, this particular app servers, and app server further contact to the database server for writing your transaction information. So guys, let's suppose this is a normal flow actually, but because this is a switch, right? So generally on switch, when we write the access control list, right? So we can control the traffic on the basis of layer 3 and layer 4 information, right? We can write the rules on the basis of source IP, destination IP, source port, destination port, right? But let's suppose now there is a one hacker. This is a hacker system. So what, because we have allowed the access of our web servers on port 80, so this particular hacker has access our one of our server, and what he had just put some malicious payload inside this server. This malicious payload gets activated, and what it will do now, this malicious payload start spreading. So he has spread it till these other servers. Now he is also trying to spread towards app server, because from web server we will allow the communication with app servers, right? So maybe this virus can reach till this particular tier, and after that, from this tier, maybe he can also reach till your database tier, because database server are the main server where your actual transaction information, all the users related information is available, and you have seen your system has been compromised easily, right? It's a switch, right? So what happens, because this virus and all this comes under your layer 7, right guys? So now you need some kind of layer 7 device here. You need some device who can work as a layer 2, but you can also get the layer 7 functionalities, guys, on this device. In that scenario, what you have to do in that case, instead of switch, just put the Palo Alto firewall into layer 2 mode, guys. And after, just put this particular enter in a VLAN 10, this in 20, or this in 30, like that also. Or you can also put all the enter into the same VLAN. Configure now your security rules, guys. Just put this particular enter in a web server zone, this put into app server zone, and this in database server zone. Configure your security rules. So if there is these kind of attacks is there, if any, it will not able to basically go till your app tier and also your database tier. Your only web server will be compromised. So that kind of protection, if you want, and you want a layer 2 functionality, in that scenario, we will put our firewall into layer 2 mode, guys. Okay. So this is the real-time example actually. So this is something with regards to your layer 2 deployment, guys. Okay. Now we can also configure interface as a H interface. So if I'll take example of PA 200 device, 200 series, guys. These particular devices, they don't have dedicated high availability ports, guys. So in that case, what if they are not having dedicated HA ports? So we have to use our data ports, which is like our Ethernet ports or HA configuration. So we can configure that time interface type HA. Aggregate interface, aggregate means ether channel, guys. Ether channel we can say, or this is also known as like port channel, right? If you want to configure port channel or ether channel, you have to create a aggregate interfaces, guys. Okay. So this is basically aggregate interface means these are the port channels, guys. Okay. Now we are having virtual routers. So the thing is, in Palo Alto firewall, if you want to configure your routing actually, so to configure the routing, you have to create the virtual routers, and you have to allocate your interfaces. You need to associate your interfaces with this particular virtual routers if you want to configure your routing protocols, like if you want to configure REP, OSPF, OSPF, BGP. EIGRP support is not there, guys. Palo Alto doesn't support EIGRP. So you can configure REP, OSPF, BGP, and also static routing. But in most of the cases, people always configure static routing on the firewall. So you can create one virtual router, and also you can create two virtual router. You can go with the multi-VR setup as well, guys, in that scenario. Okay. So basically, virtual router we have to configure for enabling the routing instance inside our Palo Alto firewall. IP addressing, we will see. Now we have to discuss bit what is the option of DHCP client server. And so guys, these things I will cover as I'll just go with the configuration. So what? Let me just start my configuration, guys, on my firewall. So I am having this particular firewall. So what? Let me just first configure the host name and all, guys, these basic things. And after it, I'll go for the other configuration. We'll go there. Palo Alto firewall. I'll give this name. Now I'll just go into my network tab. And here, guys, what? You can go into zones. You can create your zones from here as well. Like, let's create a zone. I'll create an outside zone. Okay. Here, what you have to type that you have to create a types of zone. Let's suppose you want to configure a firewall into tap mode, one interface, then you have to create that type of zone. So but I want a layer 3, so I will configure a layer 3 zone here. If you want, you can select your interfaces. Right now I don't have any layer 3 interfaces. Okay, so like this you can create a zone information from here, guys. We will discuss user identification, zone protection profile later, guys. Okay, don't worry. I'll just click over there. So I've created one layer 3 zone here. This is your virtual router. Generally, by default, you will get one default virtual router. Let me just delete because I always having a habit of using the static or user defined virtual router. So I will just create a VR01. Like this, I can create the virtual routers. Now I'll again go to the interfaces. The best way to configure these security zones, these virtual router, go inside this interface, guys. Give the comment on this one. This is my outside interface. Interface type, I'll just select a layer 3. Virtual router, I'll select this VR01. You can also create the virtual router from here if you want. You have that option here. I have created, then I will select my zone. I'll go to into IPv4. Here I can configure the IP address. So this is my outside interface. So I'll configure 192, not 192, it's 151.7.250/24. I'll configure the IP address as per this topology, guys. Okay. In advance, make the interface up. If you want to configure the link speed, so it's a VM. So in VM, basically you cannot able to modify it. If you are working in a physical devices or physical hardware, you can able to configure link speed. You can able to configure this duplex settings. Now we are having interface management profile. By default, you cannot able to ping your interfaces. You cannot able to do anything, guys. So for that, if you want to enable the https telnet ssh traffic on your data interfaces, you have to create the interface management profile. So what I just want to enable the ping, so I will just select here ping, click on OK. These are the 4 ARP entries if you want to create some static ARPs and all, guys, but other things we don't use in production, guys. Now let me just click on OK. So I have just configured this interface. Now let me configure another interface, guys. This interface is also outside interface connecting with ISP02. Interface type is layer 3. If you want, you can enable the NetFlow, but I will not enable it. VR01. And here This interface I will also put into the outside zone. So guys, in with the security zone on this Palo Alto firewall, 161.7.250/24. I'll explain you what I want to tell here. Let me make this interface up. Let me configure the ping. Click OK. So guys, you can configure in and security zone. You can configure one or more interfaces. One or more interface can be a part of one security zone, but one interface cannot be a part of two security zones. So this interface can be a part of only single security zone. So on zone, you can configure n number of interfaces. Okay. That thing also you have to understand here. Now I'll configure Ethernet 1/3 as per topology. This is my inside interface. So I'll go there. We'll give the name here like inside interface. Interface type is L3. Virtual router is VR01, and security zone I'll create a zone here. So I can also create zone from here. This is my inside zone. IP address, I'll set the IP address here, which is 10.1.1.250/24. Make the interface up, and I'll select the in management profile, which is ping profile. Let me make this interface also up. This is my DMZ interface, and here layer 3 VR01 security zone is, I have to create a new zone. I'll give this zone as a DMZ. IP address is 10.2.2.250/24, and I'll make the interface up. I'll configure the ping interface profile. Click on OK, guys. So I have successfully configured all my 4 interfaces as per this topology. I have configured all my 4 data interfaces. Now, guys, what I will do, I'll also go into my policies. I will just create one rule actually here, which is just allow all, guys. I have not basically doing anything. I'm just creating one rule which will allow all the traffic. Okay, guys, don't be confused with this, because next class we are discussing what is security policies and all, guys. Okay, and after that, what I will do, I'll go into virtual routers, and let me just do the commit here. Okay, and meanwhile, let me also take the access of these devices, and I'll just make my topology up, guys. So what I will start from this switch. I'll open this particular switch first. Let me just increase the size till here. Okay, let me open now this router here. I'll open now DMZ router. Now I'll open this ISP, Tata ISP router, ISP2 router, and an internet router actually. So guys, what I will do now, I have just completed the IP configuration and security zone configuration on my Palo Alto firewall. Now what? I'll just make now this topology up and running, guys. I'll configure the IP address, everything in this topology, and I'll see the connectivity with them. They can able to reach with each other not. When this part become active, they can able to communicate. After it, I'll start DMZ configuration, and I will check how they are able to communicate with the DMZ or not. When this thing happens, fine, and after it, I'll go for my outside topology. So I'll just go like that, guys. Okay. And meanwhile, let me also take the access of this machine. It's a Linux machine. Let me also take access of this window PC. And now what? I'll just start configuring my steps, guys. Okay, so what I will do, I'll first start with this particular switch, guys. Okay, so also when you will do this lab, just try to follow these steps, guys. Okay, don't miss any steps. I'll just go into this switch, and I'll start from this switch. Okay, I'll give the name to this switch, which is host name is inside switch 1. Okay, and after it, I'll just configure interface gig 1/2. I will run this count no switch port, means I'm just making this interface as a L3 interface, okay, which is layer 3 interface. I'll configure the IP address, which is 10.1.1.100.255.255.255.0. Do ping 10.1.1.250. I will check the I have to run the command in this way. See, ping is succeeded now. Means I can able to ping till my firewall, which means I am having the connectivity between this segment. They can able to ping successfully, right? Now what I will do in the same switch, what I'll create 3 VLANs. VLAN. So what I will do, I'll go there. I will give this VLAN 10. I'll create VLAN 20. And I'll create VLAN 30. I've created these 3 VLANs. Okay. And what? This port 10.1.2.0 subnet I will put into VLAN 10. So I'll go to interface which is gig 0/1, switch port mode access, and switch port access VLAN 10, switch port host. I will run this particular command. Now exit gig 0/2 interface I will put into VLAN 20. So switch port mode access, switch port access VLAN 20, and switch port host. Now other interface which is gig 0/0 I will put into VLAN 30. So switch port mode access, switch port access VLAN 30, switch port host. So I have just configured these 3 ports of my switch into these VLAN 10, 20, and 30. Now what I will create the SPI on my switch, guys. So I will create like interface VLAN 10, and I will configure the IP address, which is 10.1.2.100 255.255.0, and no shutdown. Now interface VLAN 20, and IP address is 10.1.3.100. I will use this subnet here, and no shutdown. Now I'll just go to interface VLAN 30. And I'll just configure the IP address, which is 10.1.4.100, and no shutdown. Exit, do show IP route, and do show IP interface brief. I'm having these 3 interface. They are in up state, which means I'm having the configuration correct, guys. Okay. Now what? Now I'll configure this particular router. So I'll go inside this router. I'll go, guys, on one by one steps. Okay, so don't worry. It's just a lab. Enable conft host name is inside R1. Let me go give this name. Okay, and also let me rename here. This is like inside R1. Okay, I just rename it in my putty session, in my secure CRT session, just for the information. Okay, now interface F0/0, no shutdown. IP address is 10.1.3.1. I will just use here 1. Then 255.255.255.0. Exit. I'll also configure one loopback interface. Interface loopback maybe 10, and IP address is 10.1.5.1 255.255.255.0. Exit out. Exit out, and if I'll try to ping to my switch IP address, which is 10.1.3.100, let's see. I can able to ping, which means I am having the proper connectivity between this segment. Now guys, if from this particular router, if I want to reach till the internet, what I will do? I need to configure one default route, right? So now I will configure one default route pointing towards this interface of this particular switch, right? So what I will do, I'll go there. I'll just configure one default route. How I can configure? I will just use this IP route 0.0.0.0 0.0.0.0 10.1.3.100. Okay. Now I have just added the default route here, right? On this switch, guys, if this switch wants to reach till 10.1.5.0 subnet, what I have to do? I have to add one static route, right? Pointing towards this router F0/0 interface. How I can do that? Let me just add one static route on my switch. IP route 10.1.5.0 255.255.255.0 pointing towards 10.1.3.1. And if I'll do the ping to 10.1.5.1, I can able to ping from switch, which means I'm having the proper connectivity. And also guys, what I will do, if let's suppose from this router, he wants to communicate to this router, who is a part of outside zone. So what he will send the traffic here. Now on this router, on this switch, we need some routing to reach here, right? So this is the outside zone, right? So what I'll also configure one default route on my switch, pointing towards firewall interface. This is how guys generally we will do the static routing in the networks. Okay, so I'll again go there into the switch, and what I will do, I'll configure one more route, which is IP route 0.0.0.0 0.0.0.0 10.1.1.250. Means I have added one default route. If you run this console IP route, you are having route proper routing here, guys. Now just ping here. If I'll go into my insights PC, this one, if I'll try to ping 10.1.1.250, I will not able to ping actually. Why I am not able to ping? Because when this inside router is sending the traffic, what he is using the IP address from 10.1.3.0 subnet, right? If I log in into my firewall, let me just log in into the firewall CLI. Admin. If you run this command, so routing route, so guys, if you see here, your firewall is not having any routes actually. For 10.1.3. subnet, do you have any routes? No, it's not having any route. That's why basically this packet is coming to your firewall, but your firewall is dropping this particular packet, right? So what I can do, I'll go into my firewall here, into the virtual routers, and if I'll go into this one, and now I'll just go into static route, and what I will do, I'll just add one route for, I'll just give the name like this, for 10.1.3.0-24. Means I'm adding the route for this network. 10.1/24. Interface is your Ethernet 1/3. And what is the next hoop? Next hoop is 10.1.1.100 IP address of your switch, guys. Click on OK. So like this, I'm having this 10.1.3.network, 5.network, 4.network, 2.network, right? 2.0 network. I will add these static route onto this firewall for all these 4 subnets here. So let me just do that right away. I'll log in. I'll go there. Let me select this one. I'll just click on clone actually. This time what I want to create a route for 10.1.2.0 subnet. I just here also change 2.0 subnet, click on OK because other thing will be remain same. I'll select this one. I'll just click on clone. And this time I will use a 10.1.4.0/24. So I'll just select a 4.0, click on OK. Now I'll just again clone and I'll just add here one network which is 10.1.5.0 subnet. So these are the 4 subnet I am having behind my inside interface. Okay, so I have added these 4 routes over there. Let me click on OK. Let me do the commit, guys. Here I'll do the commit here. As soon as this commit will complete, and if you start pinging your firewall from this router, this ping request will work. Meanwhile, what I am having this Linux machine and this Windows PC. Let me also configure them with the IP details, guys. I'll go into this Linux machine. You have to go into the control panel. You have to click on network. Just configure the IP address. Configure the IP address which is 10.1.2.1 and gateway is 10.1.2.100. That's the IP address of your switch. This interface gig 0/1. IP address of SPI. Name server is 8.8.8. 4.2.2.2. Click on apply. And we have configured the IP details successfully here. Let me just close this one. Let me cancel this one. I'll open the terminal. And from this terminal, if I'll initiate a ping to 10.1.2.100, let's see, I can able to reach my next loop, right? Even though, because in backend, ping has been completed here, right? Sorry, commit has been completed. If I'll try to ping from this Linux machine to my firewall IP, which is 10.1.1.250, I can able to do that. Ping is working here. Even though from this machine, if I want to reach to 10.1.5.1, 10.1.5.1, I can able to ping this network as well. Okay, now I'm also going into my another machine, which is Windows machine. So this one, restart later. Let me configure the IP details here. So I'll just click on ncpa.cpl. I go here and I'll just configure the IP settings here. I will use 10.1.4.1. 255, 255, 10.1.4.100, 8.8.8.8, 4.2.2.2. Okay, I have configured the IP details on this machine. Let me cancel it. If from this machine, if I'll try to ping 10.1.1.250 to my firewall, I can able to do that. If I'll try to ping to my, we can say Linux machine, which is 10.2.1.10.1.2.1, I can able to ping, means from here I can able to reach here, right? Means I am having the proper connectivity, guys. So if you see here, I have made the proper connectivity between this segment, guys. This segment is up now. Okay, and if I'll go into my firewall, which is right there, if from this firewall, if I want to ping to 10.1 1.5.1. How I can do that? If I'll use this command ping host 10.1.5.1, ping will not work because guys, in that case, it will always use the management interface. If you do the ping like this, so you have to do the ping in this format. Ping, you have to define your source. Means you have to define the interface IP address. Then host 10.1.5.1, and now I can able to ping. If you want to see the routing details, right? If you run this command, so routing route here, you can able to see all your routes. You will have a route for 10.1.2 subnet, 3 subnet, 4.0 subnet, and 5.0 subnet, right? If you run this command test routing fib lookup virtual router VR0 IP, and if you put the IP address in this format 5.1, it will give you this particular IP addresses behind this interface. So because in actual firewalls here, maybe you are having 100 plus routes, right? And how you can check these routes? So we always use this test command. Let's suppose you want to test the route for 10.1.6.5 network. See, for that network, I'm not having any route actually. If I'll check for 8.8.8.8, see, I'm not having any route here because I don't have any default route, right? If I'll check for 10.1.1.1, I'm having one route, right? Which is behind this Ethernet 1/3 interface. So by running this command, we can basically, by using this command, we can able to check our route. So we use this command a lot, guys, in the production environment, right? Let's suppose someone have given one destination IP address, right? Now you want to see this destination IP address is reachable which interface, via which interface, right? So you can run this command, you will get that interface, and you can run that command. So interface Ethernet 1/3, you will get the zone information, right, for that interface, and accordingly you can create a policies. Okay, you will see that zone information somewhere here. Virtual router layer 3, and the thing is you will get a zone is inside. Like this, you can get to know this particular IP address behind this zone, behind this interface by running this test routing command, guys. Okay. Now let's suppose we got one new requirement after our network is running fine, but let's say behind this particular router, I want to add one more subnet, which is 10.1.6.0/24. Let's suppose. What are the changes now I have to do? I will first add the subnet here behind this router. So I have to add one static route on this particular switch, right? Towards this router, and I also need to add one static route on my firewall towards this switch, right? How we can do that? Let me just do it. So I'll just go to into this inside router. I'll create one more loopback interface here. Interface loopback. I'll give the name to loopback 6. IP address is 10.1.6.6.1 255.255.255.0. So I have added this particular loopback interface, right? Now I'll go into the switchboard. In this switch, I will add one static route. How? I have to use this kind of route, IP route 10.1.6.0 255.255.255.0. Next stop is 10.1.3.1. Next stop is 10.1.3.1 because IP address of this I have 0/0 interface. Okay. I have done this thing. So if I'll try to ping 10.1.6.1, I can able to do that. But if I'll try the ping from my firewall, which is ping to 10.1.6.1, let me just do it in this way. Ping source is 10.1.1.250 and host is 10.1.6.1. Ping is not working, guys. Why it is not working? If you run this command test routing fib lookup virtual router IP and just you put the IP address, I don't have any route actually. test routing, pip lookup virtual router, then IP virtual router. I have to define virtual router, which is VR0. Okay. See, I don't have any route. If I will add the route, so I'll go into my GUI. I'll go inside this particular. It's still refreshing. What I can do, let me just log in one more time here. Okay. And I'll just add one route here, and you will be able to see if as soon as this route will be added, your ping will start working. So meanwhile, I'm also putting the continuous ping from here. I'll go there and I'll just add the static route over there. I just want to add the route for 10.1.6.0 hyphen 24 subnet. Okay. I'll always give these kind of names, guys. So by looking into this particular name, I can get to know this particular. I have added the route for this particular subnet. Interface is Ethernet 1/3, and next hop is 10.1.1.100. Okay, okay. Do the commit here. As soon as your commit will complete, you will see your ping will start work from here, guys. Just wait for this commit to complete, and this is how basically we will configure the static routing on our Palo Alto firewall. Right now, this segment is up and running. Now I'll start with DMZ. So let's wait for this. See, commit has been completed, and as soon as commit has been completed, the route is there. Now your Palo Alto firewall will start pinging, and if you run this command this time, you will able to find one route here through Ethernet 1/3 interface. Even though if you run this command, so ARP all, it will give you the ARP details as well for your next hope, guys. Okay. So by this command, we can see the ARP table, guys. And by running this command, so routing route, you can able to get the routing details. You can also run the routing if you are having multiple VRFs, right? You can also see the route on the basis of type. I just want to see all the static routes. So you are having 5 static routes, right? You can run this particular command on the basis of like interfaces. If you want to run the interface, then if you run Ethernet 1/3 interface, you will get all the route which is pointing behind this Ethernet 1/3 interface, right? So there are multiple things you can use basically in CLI to do the customization. So route destination. If I want to see the route for 10.1.1.0/24 subnet or 10.1.3.0/24 subnet, it will give you the destination is this. It's a reachable via this next hop. If I'll use here instead 24, I will use 25. So for 25, I don't have any route. So by using this command, you will get the exact information, guys. Okay. So what if I run this command in this format like 3.1.32? You also not get anything, right? So you have to add the proper subnet, guys, or proper net mask. You can also, if you are a multiple virtual routers, just run this virtual router VR01. It will give you these routes only. Here also you can basically customize them on the some next hop and all. Next hop is, let's suppose 10.1.1.100. It's 100. So you will get all the 100 next hop. So these are the few commands which we generally use in CLI if we want to deal with our routing thing on my Palo Alto firewall, guys. But test command we always use in the troubleshooting cases. Okay. Now, so this segment is ready, guys. Now what I will start with this particular segment. So what I'll go to into my DMZ router, which is this one, and I'll just configure my DMZ router first. Let's wait here. This router is coming. Conf t host name is DMZ R1. I'll give this name. And what I will do, I'll configure one IP address, which is in Ethernet F0/0 interface board. I'll configure IP address, which is 10.2.2.100.255.255.255.0. No shutdown. As soon as I have run this command, if I run this command, do ping 10.2.2.250, I can able to ping my firewall, guys. But meantime, what I will do, I will also add more loopback. So loopback, which is 10, and IP address is 10.2.2.100.255.255.255.0. Enter. Let me add one more loopback, which is loopback 20, and IP address is 10.2.20.100. So if I run this command, do so IP interface brief, I'm having these particular loopback interfaces and all, guys, on this. Do right, ma'am. And also let me just configure enable some services. I'll enable the telnet service line VTY 0 to 4, login local, exit, username is test, privilege 15, password is Cisco. I have added one username. Let me enable the HTTP. So IP HTTP server, IP HTTP authentication local. Do right, ma'am. I have enabled these things on this particular. Also, let me enable the same thing into my inside router here, guys. I'll enable the telnet by configuring the line VTY 0 to 4, login local, exit, username is test, privilege 15, and password is Cisco, IP HTTP server, IP HTTP authentication local. Do right, ma'am. Means I have just saved my changes. Okay. So in this particular DMZ router, guys, I have added these two subnets, right? Do so IP interface brief, which is 10.2.10.100, 10.2.20.100, right? If I'll go into my firewall, if I run this command, ping, source is 10.2.2.250, and host is 10.2.10.100, ping is not working. For this as well for 20.100. Why ping is not working? Because I'm not having any route on my firewall. So if I run this test routing, how I can check? Fib lookup, virtual router VR0, IP address is 10.2.10.100. No route found, right? There's no route for this subnet. So what we have to add the routes, guys. So how, even though if I'll go into this DMZ router, if I'll try to ping 10.2.2.250 with the source of 10.2.10.100, ping will not work from here as well because my firewall is not having any route. So what I have to do, I have to go into my firewall and I'll configure the routing, guys, for DMZ networks. Okay, so I'll go into this particular static routes. I'll add the route for DMZ subnet. DMZ 10.2.2.0, sorry, 10.2.10.0 minus 24. I'll add the route here, /24, interface is Ethernet 1/4, next hop is 10.2.2.100, right? This is the IP address of next hop. Click on OK. Let me select, let me clone it, and I'll do the same thing for the another route, which is 10.2.20.0/24. Click on OK, click on OK. Let me do the commit here. Commit is going on, guys. As soon as this commit will complete, you will able to see this ping will start work. Let me just do the ping with repeat count of 200. It's 99%. See, this ping has started working as soon as your commit is completed, right? Even though if this time you will go into your file, if you run this command, see, you are able to see the route here. Sometime if you will add the route into wrong direction, guys, this test command will help you in the troubleshooting. And that's the major thing with the routing, guys. Maybe you have people will add the route into the wrong direction and all. You can run this command to troubleshoot the routing related issues. Okay. Now, what I want to explain you guys here, if I'll go inside this one, if I run this console IP route, so on these devices, let's say this device wants to communicate with this segment, right? Let me just do here. If this particular router is having these two subnet as well, like 10.2.10.0 and 10.2.20.0/24, right? We are having these two sub segments, right? If people they are sitting here, if they want to communicate with this network, right? Or if these people want to communicate with this network, what we can do? Either we can log in into this router, we can configure the static route for all these subnets, right? Or on these devices, we can configure the static route for all these subnets, right? Or either what we can do, I can just configure one default route on this particular router. So all the traffic, if that particular router wants to send traffic with this subnet, see, he can forward traffic to this firewall. On this firewall we are having routing, so he will forward till this device, right? So what I can do now, let me just configure one default route here. Okay, conft ip route 0.0.0.0 0.0.0.0 10.2.2.250. As soon as I'll configure this default route, if I'll go into my inside router, if I'll try to do the telnet, okay, on 10.2.10.100, I can able to log in into my, let me put the password, which is Cisco, sorry, username is test and password is Cisco, and I have got the access of my DMZ router. So like this, basically we have to configure the routing, guys. Okay, I'll just exit from this place. If I'll go into this DMZ router, if I'll try to ping to 10.1.2.1, I can able to ping. Even though I can also do the trace route, guys. If I run this trace route to 10.1.6.1, let me just do the trace route. See, you can able to see the hops, guys, here, how this particular trace route is working. 10.1.6.1, which is behind this particular interface, right? It's taking some time. It's taking time, guys. Let me do the trace route from this machine. Okay, trace route to 10.2.10.100. It's trace RT, I think. Yeah, see, first hop is 10.2.2.250, which is a firewall IP address. Then 10.1.100, this is the IP address of this switch, right? So we can see all this trace route. Now this traffic will go to 10.1.3.1 here, which is that, see, 10.1.3.1. Now you will see the reply packet. So this is the last hop, right? So this is how, guys, we can also trace these things if you want. Actually, I've also run the trace route into my window machine. So let me just go there. See, first hop is 10.1.4.100, which is this route switch. Then it will send that traffic to the firewall, then firewall forward to here, and this will give the reply. Like this trace route will work. See, 110.1.3.1. Not here, this one. So now firewall, now you will see 10.2.2.100, the IP address of that route. Okay, so now the thing is actually by configuring these things, if we are having proper communication between this segment and this segment, right? They can reach till each other. So there is no routing actually. Routing is done properly between these two segments. Okay, even though if I'll go into my Linux machine, okay, if I'll open here 10.2.2.10.20.100, if I'll put the username which is test and password is Cisco, you can able to access the DMZ router via web browser as well. You can go to into the user access mode, run here one command is so IP interface brief. You can able to see the interface settings, right? 10.2.2 and that's the these are the IP address, right? So right now I'm having proper communication between this segment and this segment, right? Now guys, let me start configuration of my outside segment, which is this particular segment. Okay, how I can do that? I'll just start doing this configuration by I will start with ISP01 actually. So let me just decrease the size of this particular putty little bit. I'll go into ISP, which is from Tata. Okay. So I'm about to go inside. Let me change the host name first. Host name is, give the name Tata ISP01. On this router, I'm having this interface F0/0. And I'll configure this interface with the IP which is 151.7.1. 255.255.255.0. No shutdown. Exit. I'll configure another interface which is F0/1. F0/1 IP address is 181.7.1, 255.255.255.0, and no shutdown. If I do the ping to 151.7.250 IP address of my firewall, let's see I can able to ping or not. So I am having the proper connectivity between this and this. Okay. Now I'll go into, and apart from these IP address, what I will do, I will also configure one more route actually on this one for this segment, 170 segment. Okay, because this is a ISP, right? They need a proper communication with each other. IP route for 170 subnet, 255.255.255.0 IP route. Then next hop is 181.7.2. And also I'll just configure one default route 0.0.0, 0.0.0.0 pointing towards 181.7.2. Generally guys, you don't have a control of these ISP routers. Okay, so you don't need to worry about that. You have to worry about your LAN segment and your DMZ segment. But actually this is our lab only, so we have to configure everything, right? Now I'll go to into ISP2, which is Airtel. And I'm using 160 and 170 subnets. So let me just start the configuration of Airtel router here. No. What are the interfaces? So I'm using F0/0 towards the firewall and F0/1 towards the internet server router. Enable conft, host name is Airtel ISP02. This is the backup ISP. Okay, and interface F0/0 IP address is 161.7.250, 255.255.255.0, no shutdown. Interface F0/1. I will use here. I have configured wrong IP address here actually. Let me just 160 F0/0, and I have to use the IP address which is 160.1.7.1, not 250 actually. Sorry for that. Interface F0/1, and I will use the IP address which is 170.1.7.1. I will just add one route 0.0.0.0.0 towards 171.7.2 IP route for 180 network. So 180.1.7.0 to 55.255.255.0, and this network is behind 172.1.7.177.2. Do right, ma'am. I have configured the Airtel ISP successfully as well. Now let me configure this internet server actually. IP address on this particular router. So it is having these three interfaces, guys. Okay, I'll just configure this fast Ethernet 0/1 and fast Ethernet 1/0. That is more than enough, guys. Okay, I don't require this one, and also you don't require to connect with the internet. Okay, now what I'll just configure interface which is F0/1 conft host name is internet. Let me just give the name internet R1. Okay, interface F0/1, which is your towards your Tata ISP, right? 0/1, and IP address is 181.7.2, 255.255.255.0. No shutdown. Now interface F1/0, no shutdown, and IP address is, what is the IP address here, which is 171.7.2. 171.7.2, 255.255.255.0. Exit, and after that I also need to configure two static routes. IP route 151.7.0, 255.255.255.0 towards 181.7.1, 171.7.1 for 160 network line. And the thing is, if I'll do the ping to 151.7.250, I'm not having any reachability. I will not able to ping this as of now, because the thing is I don't have any route actually on this firewall. That's fine. Don't worry. Meantime, let me, okay, I'll just create the other steps later, guys. Okay, let me just save my configuration. Now what, I'll go into my firewall and I'll just configure the default routes, guys. Okay, so I will just configure one default route pointing toward this ISP with the AD value 10. And I'll configure the backup default route towards this ISP with the AD value 254. Okay, again also use 20. So because this route having the minimum AD value, so this route always will be preferred. Okay, so what I can do, I'll go into my firewall here. Let me just add my default routes. Instead, I'll add the default route. Okay, so I'll just add DR default route towards ISP01, which is your Tata ISP. Next OP destination is 0.0.0/0 means all subnets, and the interface is Ethernet 1/1. Next OP is 151.7.1. and the metric is 10. Just go with 10 value, click on OK. I will add one more route. Default route towards ISP02, which is your Airtel. 0.0.0 interface is second interface, which is connecting your Airtel ISP, and next loop is 161.7.1. And here we have to basically put the metric 254. Why we are putting this metric value 254? Because if you will put two routes with the same value, these route will not be accepted. Let me just delete here. If I'll go with the default value, if I'll try to add, it will add, but when I'll do the commit, I will get some errors, guys. Okay, so I will just use here 254. Let me click on OK. Let me do the commit now. Now the main thing, guys, comes. Okay, now we will see how path monitoring works, all these steps actually. So let's wait for this commit to complete. Okay, as soon as this commit will complete, let me just try to ping to this IP. Ping for this is working. Let me also try to ping for 160. So 161.7.25, this IP address is not pingable. Okay, not an issue. Ping source, let me use 161.7.250, and host is 161.7.1. Okay, it can able to do that. 172.1.7.2. It's not able to do that. This IP is not pingable, which means there is some issue with the route here. Like, just let me just check. So IP route 160 is reachable via 171.7.1. So IP, let me just so IP interface brief in 171.7.2. Ping to 171.7.2. Ping to this one is working fine. Let me just see the config here. So IP interface brief F0. Okay, this interface is in down. That's why, guys. Okay, so let me just make this interface up. Interface F0/1. No shutdown. I forget to make this interface up. As soon as this interface is in up state, I can able to ping, which means now on my this segment, I am having the proper connectivity. Let me just ping both. See, this is pingable and the other IP address of firewall is also pingable, right? Which means I am having the proper connectivity between this segment as well. And also if I'll go into my router here, if I run this console IP route, so routing route type is static. You will see I'm having these two default route. One pointing toward this, another pointing toward this. See, having metric 10, other one having 250. See, these are the flags. This is a static route and active state. A means active. This route is a static, but it is not active right now. Same thing if you go into your firewall, click into more runtime stats, you will see both the routes here. But if you go into the forwarding table, it will show only one route, the active route only, guys. This is the only active route which I'm having right now. So the thing is, what I will do, I'll just go into this internet server, and what I will do, I'll just create one loopback interface loopback 8 actually. Okay. And I will give the IP address, which is 8.8.8.8. Not 8.8. Let me just skip some 80.80.80.80, 255, 255, 255, 255. I have given this particular IP address over there. Okay, let me just do the right mem. Now, if I'll go into my inside machine, let's say I'll go into this window machine. If I'll try to ping to 80.80.80.80, request timeout. Why request timeout is coming? Because if I'll go into my firewall into policies, I am having the security policy, but I don't have any net rule, guys. Okay, so what? Let me just add to net rule. Don't worry, guys. We will have a lots of discussion with the net rules. Here I will create two pet rule. Pet rule 1 towards ISP01. Okay, traffic coming from inside, going towards outside. Interface is this. Translation will happen on dynamic IPN port. Interface address, I will use first interface, and the outs interface, I will click on OK. I will select this rule, I will clone it. And this particular net rule is towards ISP2. This is the pet rule 2. I will use the interface Ethernet 1/2, and here I will use Ethernet 1/2, and IP address is 160. Let me just do the commit here, because we also have to basically configure this pet rule. Let me come back here. Meanwhile, commit is going on. Okay. And as soon as this commit will complete, guys, you will see the ping will start working from here. 75%. See, it has committed in a backend, guys. 99% means commit has been completed, and you will see right now all the traffic take care by the ISP1, guys. Okay. ISP1 is taking care of all the traffic, and this ping is working. And if I'll go into my internet server here, and if I run this command debug IPICMP packets, see, I am receiving the packet from 151.7.250. Why? You can see this IP where it's a padded IP address, right? So now if anyone send the request towards the internet, what that traffic will go through your ISP1, which right now, what is the traffic flow, guys? Here I have the initial ping from this machine, right? Traffic going here, then this was switch forwarding to this Palo Alto firewall, this Palo Alto forwarding traffic here, then this traffic reaching here. On this one, I am having this 80.80.80 server, right? Then he will give the reply. This is the path right now, guys. Let's suppose what happens. Let's suppose due to any reason, if this interface goes down, or if this interface goes down, means this particular path is down now due to any reason. So what I can do, I'll go into my firewall. I'll go into this ISP router. I'll just make one of the interface in down state, which is, let me make fast Ethernet 0/0 interface. Conti interface F0/0. I'll just make this interface down. Right now, my path is down here. Okay. If you go there, if I refresh, still this route is in active state, guys. And you will go to into this machine, ping has start dropping. So guys, right now automatic backup is not happening. What you have to do, go into your firewall. You can go into your firewall, and afterward you go to into your static routes, look for these default routes, go on this route. What you can just disable this route, or either you can delete this one. This is the way which you are having. If you want, guys, automatic failover, what you have to do, if you want automatic failover, automatic route failover, what you have to configure the path monitoring, guys. We will monitor the path actually. So as per our topology, let me go into my topology here. So what if this particular path goes wrong? When this path goes wrong, maybe this next hop become unreachable, right? Which is 151.7.1, or maybe this interface goes down, right? So what we can monitor the next hop, as well as we will monitor one of the IP address as well, right? Maybe we can also monitor the IP address which we have configured into this interface, or any public IP address which is there. We can monitor any IP address, right? Let me also add one more loopback here with this IP address 8.8.8.8, and I can monitor 8.8.8. So if this IP become unreachable, or either this IP become unreachable, then only I will just make sure my this route go in down state and this route become active and data start forwarding in this direction. How we can do that? So let me just do it, guys. Let me just configure the path monitoring now. So what I can do, I'll just go into this internet router, interface loopback. Let me add one loopback maybe 50, and IP address is 8.8.8.8.255.255.255.0. So now this particular IP address is active in this internet router. Okay. Now I'll go into my firewall. I'll go into first default route. Okay. And if you see this path monitor, I will enable this path monitor. Failure condition is any or all. I will explain what is the meaning of any and all, right? Frames and hold time is 2 minutes, guys. So what I will do, let me just first add one route here. Okay. So right now what I am just monitoring next hop. So I will just give a next hop. Okay. Source IP address, I will use this IP, and destination IP 151.7.1. I will just monitor the next hop. Ping intent will send it will send the ping messages every 3 seconds. If 5 ping message has been lost, in that case your route switchover will happen. So it's a next hop. So what I will do, I will send the ping interval in every 2 seconds. And what I only want to, if my 3 ping has been lost, I want the route switchover. I can just configure the monitor in this way. I'll add one more monitoring. Right now I'm monitoring the, we can say DC IP. Okay. What is the IP? 8.8.8.8. And sources, I will use the source this one, and DC address is 8.8.8.8. And I will just make the every 3 seconds just send the ping. If 3 ping has been lost, just do the route switchover. Because sometimes your this IP address is somewhere like apart, right? Somewhere do. So that's why we have used like that actually. Now guys, if you see here, failure condition is any, means if next hop become unreachable, either this IP become unreachable, your failover will triggered, guys. Your route failover will triggered. If we will select this all option, which means both condition needs to be filled, means both condition needs to be fulfilled, then only switchover will happen. So that's why I will go with any here, guys. I'll always prefer to go with any. And this preemption hold time, right? It's 2 minutes by default. Just remove, just put here 1 minute actually. Click on OK. I'll go into another ISP. I enable the path monitoring. Any preemption hold time is 1 second. Preemption hold time means, guys, when your, let's suppose right now failover is happened, your secondary route become active. Now after some time, if your primary ISP comes back online, what happens? In within 1 minute actually, your primary route become active actually. That's the preemption hold time. That's why this hold time I'll always prefer to keep 1 minute, guys. Okay. Otherwise it will take around 2 minutes for the switchover. I'll enable the next hop. I'll monitor the next hop. Source is 161.250 and next hop is 167.1. 2 interval, and I will always want to send 3 pings. So in 6 seconds, my route switchover will happen actually. Let me just ping like DCIP, enable the DCIP. I will select the source is this, and DCIP is 8.8.8.8. Same thing, 3 seconds, 3 ping. Now I'm having these route switchover. Okay, let me save it. Let me do the commit here. And meanwhile, what I will do, I'll go into my ISP. I'll just make that interface off just for testing purpose. Let's wait for this commit to complete. As soon as I make this interface, see traffic is flowing, start flowing, right? So right now you are able to, you can see here two types of debug, right? 8 for 80 for 8. So this 8 for 8 IP address 8.8.8, these are the path monitoring basically traffic, because your router will send the try to ping to this IP address 8.8.8. So you will able to see these IP address here, guys. Okay. Just look for 80 traffic. Right now 80 traffic reachable via primary ISP, right? And also if you go to into your routing table, your primary route is in active state, right? So what I can do, and also static path monitoring, if you see path monitoring is in active state, status is also up, right? Monitor is also succeeded. If you see status is success, which means they are basically able to ping that IP address. Now what I can do, if I'll go again into my router, which is ISP, and if I this time if I'll make my interface down, make the interface down, you will see some ping will start dropping. See, you will see some drop here. And also if I refresh this one, see, your route monitor is failed for this one. If you go to into the forwarding, now your route become active from the another path, right? And if you go to into this machine, see ping has start working. So there is only 2 ping drop and your route switchover occurred, guys. So this is how your path monitoring works, right? If this interface again comes online, let's suppose I'll just run this no shutdown. So this interface is an up state. If I'll go there in monitoring, let me refresh. See, basically now monitoring succeeded, but it is in hold state because it's a primitive hold time, which is 1 minute, right? You can monitor right now 47 seconds is active. And when this hold time is finished, you will see the route, which is 151.7.1 will be active here. Just wait here, guys. Wait for 1 minute. Okay. 34 seconds. Right now, if you go there into this, right now all the traffic is going through 160. For 80, you are seeing 160 IP address, right? But as soon as this whole time will be finished, let's wait 18 seconds, 17. And after that, you will see the route from primary ISP will be inactive. So that's how your path monitoring works. See, 8 seconds, let's see 6, 5, 4, 3, 2, and 1. As soon as this will 1 go there, refresh it. Now your route from 151.7.1 is in active state, and you can able to see the traffic from 151.7.250. So this is how, guys, your dual ISP failover works actually by using the path monitoring. Right now we are using path monitoring and we are achieving our task, right? Sometime what happens right now, this interface goes down, means next to become unreachable. If this interface goes down, means ISP of ISP goes down, right? In that case also your path monitoring will trigger. So what I can do, if I'll go into this one, if I'll make this interface in down state, let's see what will happen in that case. So I'll go there, interface F0/1. The other part of this, I'll just make this interface shut down. I'll go into my firewall. And this time also your monitoring will fail. what command I have run. Let me just see. Okay, is interface in down state. See, it's just bent down, guys. And now you will see your secondary route is in active state, and now this time your ping will start working, right? So there is a some drop, guys, right? There's some 4 packet drops. And if I'll go into this one right now, all the traffic will be coming from the secondary ISP, right? Now, if this interface again comes back online by run this command no shutdown, make this interface up, go into this one monitoring section, and you can monitor it here. See, it is in hold state, and 1 minute your route from primary ISP will be in active state. So this is, guys, your path monitoring, and this is how we will configure your path monitoring, guys, in your dual ISP cases where we are having 2 routers. Okay, now what I can do, let me just go into my topology. So this is how we will configure the path monitoring. Now let me just move towards the topic, which is your policy based forwarding, how we can configure the policy based forwarding, guys. Okay, so generally policy based forwarding or policy based routing, like this thing is also known as a PBR, policy based routing, but in Palo Alto this thing is known as a policy based forwarding. This is a Cisco terminology. So what happens right now, I'm having these 2 paths, right? As per my topology, I'm having these 2 paths. So the thing is, if traffic is coming for, let's suppose, this particular networks, if traffic coming from these networks, what I want, this traffic will always go through this secondary ISP, and the remaining traffic will go from the primary ISP. If I want this kind of setup, means for the subnet which is 10.1.5.0/24, 10.1.6.0/24, and 10.1.3.0/24, I want these 3 subnets traffic will always go via secondary ISP. If secondary ISP become unreachable, then that traffic basically will go via primary ISP. If you want to configure these kind of things actually in your network, so generally why we use this particular concept actually? Sometimes what happens, let's suppose you are having few users into some specific networks, right? And they want to just access some part of your data center, and in that data center you are running some mission critical application, right? So what you have purchased some proper bandwidth through the secondary ISP, and always you want your traffic will go through this ISP for these mission critical applications, right? If you have that kind of setup, in that case we use policy based forwarding, guys. Okay, I'll have, if you go into this, I have put these 2 documents, guys. You can go through with them if you want to know more about the PBF, but these are the few use cases. I'm having primary ISP, then backup ISP, right? I can configure this PBF so my users can basically send the traffic through the specific interface. So what? Let me just show you the configuration of this thing, guys. So to configure the PBF, what you have to do? Go to into the objects, into policies, and you will see policy based forwarding here, guys. Just click on into this one and just write the PBF rule 01. This is the first rule, like if zone is inside and source address, if source is coming from 10.1.3.0/24 network, or traffic coming from 10.1.5.0/24 network, or traffic coming from 10.1.6.0/24 network. Okay, you can define any destination if you want. Let me just define if destination IP address is 80.80.80.80, and another IP address is 8.8.8.8. if these are the two specific destinations, right? You can define your applicant live if traffic coming for, let's say, ICMP traffic. I will use here ICMP application. I will also use here ping application. Don't worry, guys. I'll tell you what is the difference between ICMP and ping. This application, okay? Ping. PING. Okay. Or what I can do, let me just delete this thing. I can just allow for all the application. Okay. You can define the services if you want. And forwarding, what you can do? Action is just forward. Egress interface, just use Ethernet 1/2 interface, which is ISP2. Next hop is IP address. And what is the next hop? 161.7.1. Enable the monitoring, guys. Path monitoring we have to enable. Just enable the monitor. So like PVF monitor profile. Okay. I'll give this name. I'll just want failover. So what if I'll miss the 2 ping actually? If they will send a ping, if I'll miss 3 pings in an interval of 2, that time failure will occur actually. Okay. Disable this rule if next hop or monitor IP is unreachable. Here we have to define the next hop IP, which is 161.7.1. This IP become unreachable. This rule will be disabled, and after that your traffic will go through the primary ISP. Okay. Now click on. You can also schedule that policy if you want. Let me just click on OK. Let me just do the commit here. Okay. And what I will do, I'll go into my this router. Let me just disable the ICMP debug. Okay. Undebug all. Okay. Undebug all. Why it is not coming? Okay, and all. It will take this thing. Now I have disabled the debugging for ICMP traffic, guys. Okay, I have configured this PVF rule. So now, according to this rule, right? If traffic coming from these routers, so if I'll go into let me just enable few things into this router. Like I want to enable the telnet line VTY 0 to 4, login local, exit, username is test, privilege 15, and password is Cisco. I have just enabled these things. What I will do, I will just do the telnet from this inside router. Okay, so I'll just go into this one. And what I will do, I'll just do the telnet on IP address, which is 80.80.80.80. Username is test. Password is Cisco. I can able to access it, right? I got the access of my internet router. If in this router, if I run this command who, just wait here and see the IP address. See, IP address is 161.7.250. IP address of your secondary ISP, right? Which means right now your traffic is coming from the secondary ISP, means our policy based forwarding rule is hitting, right? If I run this can debug IP TCP packets, if I'll go into this router, if I run any command, like let me just run so version, you will see the debugs actually here. Traffic is coming from this one 161.7.250, and just go to into this router. If you run this command test, so routing route, let me just see, there is a one command for PVF actually. There is a command for ECMP. Okay, let me just, there is a one command actually, I forget that command. So let me go down. So if I run this command, show pvf rule all, this will basically, this command will give you the all the pvf related rules. Okay. And what? Show session all. You can also run this command, show session all, filter application which is telnet. Right now you will see that traffic coming from here going to this network, and that's the IP address, means secondary IP. There is a one session. And if you run show pvf policy based forwarding rule all, you will get this is the rule I'm having. And right now this rule is in active state and it will forward traffic towards this IP address, right? So pvf, let me press the question mark, forward domain and all, you can see all this information rule. It will give you all the rule details. Okay. But there is a one more command is there. This pvf is in active state or not, right? I forget that exact command, guys. Let me just see if I can get that command somewhere here. So pvf rule all. We can also run this particular command, guys, test command for testing the pvf policy. Yeah. So either we can run this test command, either we can run basically, so running pvf policy, it will give you the all the pvf related policies, guys. Okay. If I'll go there, let me just go into my network tab here, into more runtime stats, forwarding information base, static routes, and you will see all the information here. If I'll go into the policies, let me just see if I can able to see anything here. You will also get the hit count, guys. Okay. By looking this hit count, you can able to see your rule is hitting or not. Okay. What I can do this time, let's suppose my secondary ISP become unreachable. Okay. So what I can do, if you see here, I'm having one telnet session which is active right now. If I'll go into my ISP2, which is Airtel, I'll go into conft. If I'll disable the interface, which is F0/0, I hope. So this F0/0, if I'll disable this interface, which means this time my PVF will change, right? See, your session has been hanged now, right? Your session has been hanged actually. I'm not able to do anything because now your PVF rule will be inactive state right now. You can also track here. See, right now it's in down state. So by looking into that information, you can able to basically see. And if this time, if I'll go into this router, interface router, let me run this command because this session will be terminated after some time. Meanwhile, what I can do, I'll go there and let me clear the session, clear session all. And as soon as I'll clear the session, I can able to at least get the prompt now. See, go there. That session has been hanged actually. So what? Just disconnect. Just reconnect one more time. Still this session in hanged state, but after some time you will get that session. See, it's resuming the session. It will take some time. It's just a devices which we are running on VM. That's why it's taking some time. Okay. So this is how, guys, your policy based forwarding works. And this is how we will configure these PBF rules. So the thing is now, right now, due to this PBF rule, our traffic for these subnet will go via this interface. If this interface went down, traffic start going through the another interface. That's the main purpose. Let me just open the one console one more time for this one. It will resume the connection. It's trying to resume it actually. Control Shift 6. Okay. Okay, not an issue. Let me now go to into this one. Let me just make this interface up state. So like this, basically we can configure the policy based forwarding as well, guys, into our, maybe after some time this router become active actually. If I'll go into my Palo Alto 5 again, if I run this command show PBF rule all, you will see right now this is in up state, right? So this is also keeps monitoring, and according to the availability of the ISP, this rule will be in active state, otherwise this rule in a down state, guys. This is how we can also verify the PBF, guys. Okay, now let me explain, guys, now what is ECMP. ECMP stand for equal cost multipathing, guys. So the thing is, by using equal cost multipathing, what? So right now what I am having my firewall, so I'll just use this particular topology here. So if you see here, I'm having, this is my primary ISP, this is my secondary ISP, right? Let's suppose I want to just share the load between these two ISPs. So either we can use PVF, policy based forwarding. If we want to do the load sharing according to this one, let's suppose this is a 300 Mbps link. This is a 100 Mbps link. So what we want? I want around 70% of traffic I want from this interface, and remaining 25% traffic will go through this interface. Or another way, what I want, let's suppose this and this is a link of 70 Mbps, and let's say this is a 30 Mbps link. So I want if 10 packet is initiated by my inside machines. In that case, I want 7 packet will go from this interface, and remaining 3 packet will go through this interface. If you want to configure these kind of load balancing, guys, what you have to do, you have to go with equal cost multipathing, which is a ECMP concept. How we can do that, how we can configure it, let me just show you guys. So what I can do, I'll go into my firewall, I'll just disable this particular PVF rule. Okay, and now what, I'll go to into my network tab. Let me just, I'll go to into virtual router. Let me just enable the policy based forwarding, guys. Static routes. If you see here, you have a this in route setting, you are having ECMP. If you select on this one, which means we are just now enabling the ECMP. We select this option, which is for symmetric return, guys. Okay. Stick source path. Maximum path is 2. So the thing in ECMP, you can load balance the traffic between 4 ISPs, guys, 4 ISP connections. You need minimum 2 paths here, and I am having 2 paths as per my topology, right? So what I will just put here, maximum path is 2. There are 4 methods for basically load balancing the traffic. First one is IPU Medlo, second one is hash, third one is baited round robin, fourth one is balanced round robin. So what I can do, guys, let me just go with the balanced round robin. If I'll use this method, which means it will do the 50-50% distribution. I have just enabled the ECMP. I'll go into static route, and you have to basically go into this static route, and then this one you are having metric is 10, right? In the other static routes, now go and just configure the metric value is 10 here, means when you configure ECMP, you can have the same metric value into your default routes. Click OK, do the commit here. And now we will see different things in ECMP, guys. Okay. How we can configure? It will do the equal cost load balancing, guys. Okay. We have to configure our default route with the same metric value. We need to configure to net pet rule, which is already there. We have to enable the ECMP, we have to select the path, and we can select a balance round robin. We will check all the methods, guys, don't worry. Okay, now let me just see. So commit has been succeeded. If I'll go into more runtime stats, right now you can able to see here, I am having both route with the same metric value, and flag you will see A means active, S means static, E means ECMP is enabled. Means you see both route right now in active state. One with Ethernet 1/1, other one is with Ethernet 1/2. Right? If you go into the forwarding information base, see, you will see both the route is in an active state right now. Okay. And what I will do, if I'll go into this particular server, let me disable. And what I will, if I run debug IP ICMP, so guys, there is a path monitoring is enabled. So what, let me disable this path monitoring, because I want to show you the equal, how the equal distribution happens. Generally in real cases we will enable the path monitoring, right? But for just for the lab purpose, I am disabling this path monitoring into my, or what I can do, I'll just monitor the path. Actually I'll go to into my this router, enable the, I'll just disable the path monitoring on this IP. I will just monitor the next step. Okay, to this one also I'll delete this. I'll enable one path actually only, because otherwise you will see some unnecessary ping is coming into this one. Okay, because when I will disable, you will not able to see any pings. You will only able to see the actual request, guys. Okay, let's see here. Let's wait for this commit to complete. And you can also run so routing route. If you run this command, you can able to see your routing table by looking into these things, which means ECMP has been enabled. Let's wait here for this commit to complete. Commit has been completed. Still I'm getting the traffic for this one. Okay, what I can do, let me go into this one, this machine. Let me just disable it. These are the coming from that machine. Okay, now you will not able to see any ping request here, right? And ECMP has been enabled. So the thing is, if I'll go into my this window PC, and if I'll do here ping to 80.80.80.80 with a -T. So I have sent here 4, then 5, then 6. Let's suppose 7 and 8. So I have sent total 8 packets. Okay. And if I'll go into this router, you will see here first packet is from ISP1, then second packet from ISP2, then first packet from ISP1, then second packet from ISP2, ISP1, ISP2. So here what is doing? It is doing the balanced round robin, guys. Means it is just doing the 50-50% distribution. If he received like 8 packet here, 4 packet it will go for ISP1 and 4 packet will go with the ISP2. You can calculate these packets count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the unreachable packets. Okay, just ignore them. Just look for these packets, the actual ones. Okay, look for this one, because there's some DNS packet is coming from the inside hoods. These are the packets, right? So they have sent 8 packets, and you can see all these 8 packets basically coming here, guys. Okay, So right now they are doing the 50-50 distribution, right? If I'll go into my inside switch, which is this one, if I do the ping to 8.8.8.8 with the repeat count of maybe 20. All 20 packet has been I have sent. Now you will see first packet from primary ISP, then secondary, then primary, then secondary, then primary, then secondary. Means here equal distribution is happening right now, right? But let me just change the distribution this time, guys. What I will do, I'll go here into my virtual router, ECMP. What I want the weighted round robin, which means I want to send my 70% traffic from one ISP and remaining 30% traffic from the secondary ISP. If I want this kind of setup, so I have giving here weight values, guys. Means 70% traffic will go with the primary ISP and 30% will go with the secondary ISP. Go there. Let me do the commit here. Now let me just see. We can run this command if you want to see ECMP. If you run this default ECMP, yes, it will give you the ECMP related stuff. So routing, route, ECMP, yes, enter. It will give these are the two routes which we are paid value is 70%, 30%, right? Let's see this particular traffic flow this time. Its commit has been completed. Let me go there. Let me just go to into inside switch and let me just do the send around 20 packets, guys. If you see these packets, first packet from ISP, then secondary, second packet from ISP2, then first, then second. So the thing is here they are doing still they are doing the equal, not equal, guys. If you calculate the packets, okay, let me just do the calculation of what I can do. Let me not, I will just send 10 packets, okay, instead of 20. Let me just send the 10 packets from here, okay. So you will able to see 20 what I will just send 10 packets. So this time if you will see one packet from ISP1, then second from ISP1, third from ISP1, fourth from ISP1, fifth one from ISP1, right? And this is all, this packet is also, so let me just calculate packet 1, then 2, then 3, then 4, then okay, I'm not sure why I'm getting this unreachable packets. And okay, let me just undebug all. Okay, I just do the calculation of these packets. So you will basically observe 7 packet from ISP1, remaining 3 packet from ISP2. Right? This is the first packet, then second, then third, then fourth, then fifth, then seventh. 6 and 7, right? 7 packet from ISP1, remaining packet number 1, packet 2, and packet 3 from the secondary ISP, right? So here what they are doing the distribution on the basis of weight values, means 70% traffic from ISP1 and 30% traffic from ISP2, guys. Like that also we can configure the ECMP. Okay. Now, if I'll go there into my virtual router, if I'll go to into ECMP, I'm also having one more method, which is IP modulo. In IP modulo, what happens, guys? They will calculate the modulo value. They will just try to calculate the parity value actually. If parity value is even, they will send the packet from primary ISP. If the parity value is odd, they will send the traffic from the secondary ISP, right? If you want more details regarding these algorithms and all, you can check these details here, guys. Symmetric return is to cause the return packet for the egress out on the same interface. We select this one, which means we want the upcoming, or we can say reply packet also through the same interface. Okay. So now these are the load balancing algorithm. And IP modulo what uses a hash of the source and destination IP address. So what they will just calculate the hash value on the source and destination IP in the packet header to determine the ECMP route to use. Use a hash value source available on PAN-OS later. Use the hash value for source and destination by the default IP hash method. So we can also go with the hash value in IP modulo uses a hash value for source and destination IP address, right? So like that, we can also use these two methods, but I have seen in the industries, people are using weighted round robin in most of the cases. And sometimes people don't configure this ECMP, guys, because ECMP configuration is a little bit complex configuration, right? If you have a proper load balancing, then only go for this ECMP configuration. Otherwise, just neglect and go with the PVF, policy-based forwarding. Okay, because policy-based forwarding is easy to configure, but ECMP sometimes become complex, guys. Okay. Now, if you want the more detail regarding these methods and all, you can go through with documents, guys. Okay. So if I will change the method, like let me just change the IP modulo, select here, let me do the commit. In that case, it will basically check the modulo value. It will calculate the hash value for source and destination IP, and it will do the data forwarding. That's this particular method is good. If you want, like for same source and for same destination, if you want all the traffic will go through the same ISP. In this scenario, this method is helpful, guys. Okay, so these are the different cases. You can use these things, guys. Now if I'll again go there, okay, if I run the debug IP ICMP packets, if I'll go inside this switch, if I'll try to ping, see, you will see the traffic through the same ISP. If I'll go there, if I'll change, if I'll just configure the sources 10.1.3.100, it is just again it is taking the same ISP. If traffic is like 4.100, it is taking the 150 still. So guys, it is just calculating the hash value, and like no one knows which which method it is using for that actually, because these are the Palo Alto algorithms and we are not aware about which algo they are using and how they are calculating these values. So this is how basically this particular ECMP works, guys. I have put these two Palo Alto links. You can go through if you want more details with these things. Okay. Now, guys, I need around 10 more minutes to show you this DHCP configuration, right? So how I can do, if I'll go into my Palo Alto firewall, into interfaces, and if you go there, we are having this DHCP option, right? So what we can use this Palo Alto firewall as a DHCP server, guys. So the thing is, when we use this Palo Alto DHCP server, whatever client you are having behind that interface, they will start getting the IP address from DHCP. Okay. You can also configure Palo Alto as a DHCP relay agent. So what if Palo Alto receives any DHCP request on the interface, he can just forward that request till the DHCP server. And you can also configure like on this Palo Alto interfaces. If I'll go there, I'll have this particular interface as well, right? If I'll configure this interface, let me configure a layer 3. IPv4, I can also configure this as a DHCP client. So now my Palo Alto I will get the IP address from the DHCP server if we have any DHCP server, guys. Okay. That time my Palo Alto firewall get the IP address from DHCP server. Okay. So these are the things which I want to discuss with regards to your DHCP. Now let me just configure DHCP server setting here. Generally, it's not a recommended one, but let me just do it. So I want to enable the DHCP server. Let's suppose behind this Ethernet 1/4 interface. Mode is enabled. Least time ping IP when, so when my Palo Alto allocate any IP address, it will just ping that IP pool. Let me just configure that pool 10.2.2.0, 10.2.2.10 to 10.2.2.20, or maybe I can give 100, not 100, 90. Means my firewall basically provide the IP into this range. You can also do the reserving if you want to reserve. In option feed, you can define gateways 10.2.2.250. Subnet mask is 255.255.255.0. DNS is 8.8.8.8. Secondary DNS is 4.2.2.2. You can also send all these settings, guys, from the DHCP. Let me click on OK. Let me do the commit here. And right now in my topology, I'm having this router, right? So I'll go into this router, which is my DMZ router. By default, it is having the static IP address, right? Do so IP interface brief, right? But just for the testing purpose, what I will do, I'll go into this interface. I'll just type this kind no IP address, an IP address from DHCP. Let's wait for this commit to complete. Commit has been completed. View the allocation. See, it has allocated 10.2.2 IP address to DMZ router. This is the MAC address. If you go into your DMZ router, so this it happens very quickly, right? So IP interface brief. This router have get the IP address from DHCP server. So like that, you can configure Palo Alto as a DHCP server, guys, right? If you are having any kind of DHCP server, so let's suppose what I can do. Let me do here. Let me go to into this interface. An IP address which is 10.2.2.100. I'll configure this IP address 255.255.255.0. So it will take some time. It will remove the DHCP settings, and what I will enable the DHCP services in this DMZ router. Let me configure this particular router as a DHCP server. So IP DHCP pool LAN. Then I will define the network 10.2.2.0 /24 subnet 255.255.255.0. Let me just see. I think I have to define the length here. Subnet prefix length is 24. Default router is 10.2.2.250 or maybe 10.2.2.100. Oh, I don't need any default route on the this interface, right? If you want DNS, you can do DNS server is 4.2.2.2. Do so IP DHCP. So IP DHCP bindings. Right now there is no binding. Now what I will do, I'll go into my Palo Alto firewall. This into what first I will just delete this DHCP config here. Now let me just go to into my Palo Alto interface here. This interface, and instead of this static IP, what I'll just configure the IP address via DHCP client. Do the commit. So I have just configured the DHCP settings in my DMZ router, right? So IP DHCP pool, I'm having this particular pool, right? It's not having any binding as of now. Let me just see, commit has been completed. It's not get any IP address till now. So IP DSC binding, I think this router is not providing this IP from DSC correctly, that's why. Because we have to disable one thing. Actually last time when I have configured the same thing on this routers, I have disabled one thing. Actually I forget exactly what I have disabled. So IP DSCP server statics, server static, it is running these services. It is having that pool, but it is not providing the IP. But if you are having the proper DSCP server, your firewall basically get that IP address from there. This server is not working. Maybe I'll test this thing. So I'll this small thing I'll show you guys in the next class. Okay. So these are the thing which I want to cover with respect to your day 4, guys. This session is bit longer, guys, but we have to cover so many things. That's why let me just now stop the record.